Today we are going to make a 1-bit full adder. 1-bit full adder takes 3 1-bit numbers and produces 2 bits, which are the sum and carry. Let's start by creating a new circuit. From File, select New Circuit, and add a new circuit. The full adder design that we are going to use today is based on the circuit that I'm showing now. We have a 2-level logical circuit for producing the carry, and we have 2 XORs for producing the sum. So let's start and add the gates and create the circuit in LogicWorks. So we need 3 2-input AND gates. We can select the component from the right palette. So this is the 2-input AND gate. I'll drop in 3 instances of the AND gates. And we need 1 3-input OR gates. So I'll bring in a 3-input OR gates that aggregates the output of the AND gates. Okay, the 3 outputs are connected. And then we need 2 XOR gates. First and second. Okay, so the output of the XOR at the bottom is our sum, and the output of the circuit, combinational circuit at the top, is the carry out. We can call it C out. As soon as you put a name for any of the signals, they will show up at the timing panel. That's where we can see the simulation and verify the values. So let's define our inputs. First of the signals, we can call it A. And the second input, we can call it B. And the third input, we can call it C in, short for carry in. Okay, now let's create the other combination. So we have A, B at the first AND gate. We create A, C in at the second input, and we can create a B, C in at the second input. So that's all the combinations we need. A and B, C in and A, C in and B. If we have any of these 2 combinations, that means we are going to have a carry out. And at the bottom, we need to have XOR of all the 3 inputs. So let's get A, let's get B, and let's get C in attached to the input of the 2 XOR gates we have. So that's the full circuit. Let's simulate this circuit and make sure this is working as expected. For simulating the circuit, we have several ways. We can test with binary switches. Let's put some binary switches and verify. So from the right palette, we select the binary switch. I need 3 binary switches. If you double click on binary switch, you can drop multiple instances. So I'll drop 1 instance here, 1 instance here, and I'll drop another instance here, and then extend the wire. If you press escape, it will release from the mode that it's inserting multiple instances of the binary switch. Let's extend the wire. Okay, now I have all the binary switches I need, and I can drive the input, and the circuit looks complete. So let's start the simulation. Simulation is already started. We can stop and then configure the simulation to show the simulation values, so we can see the value of the wires, every wires on the circuit, and verify the correctness. So I enable show values. Then we can start the simulation by pressing the Run Simulator button up here. And the simulation is now starting. So first thing to verify, let's verify 3 combinations. This is the list of all combinations we can have for these 3 input, 2 output circuit. Let's verify the first combination. When all the inputs are 0, we expect the output to be 0, and that is correct. The second combination we can try if we have all the inputs equal to 1, both carry out and sum should be 1. That is also correct. Let's verify one other combination. Let's say verify 1, 0, 1. In this combination, we have a carry out because 1 and 1 are added and produces the carry. And the sum is 0. So that combination is also correct. So the circuit is all good. We can stop the simulation, save this circuit. This is our first symbol. Call this symbol, I call this circuit 1-bit adder. Full adder 1-bit. Okay, our circuit is ready. The next step is to create a symbol from this circuit. This symbol allows us to create a wrapper over the circuit that we have in here and add this to a library. Then we can instantiate multiple instances of this circuit in an abstract way, and we don't need to see internal of the circuit. This is the steps we take when we want to create a bigger design. Let's save this file as another file. So we build our symbol design based on this file, identical file. I'll name it file adder 1-bit symbol. And I'll save this as a new name. Now, for creating a symbol, we have to remove all the drivers and add ports instead. So I'll remove the 3 signal drivers I have here, the binary switches, and I'm going to replace them with ports. So from the right palette, you can filter ports, and then there are input ports, output ports, bidirectional ports. Select port in, that's the input port, and bring in 3 instances and attach to the inputs A, B, and C in. Also bring in 2 outputs. If the orientation of the component is not correct, right click, and then you can flip it horizontally or vertically to get it right. If you flip horizontally, you can get it attached to the circuit properly. And I'll bring another output, and we can flip it horizontally again and attach to S. Now we have all the ports, but none of the ports have name. Let's name the ports, otherwise they won't be identifiable from outside. Let's name this one A, second one B, third one carry in, and the outputs, first output carry out, and the second output sum. Okay, our symbol circuit is ready. Now the next step is to create the symbol with the interface and add it to a library. So let's do that. From the file, we select a new, and this time we select device symbol. Let's open the device symbol here. We can be creative, create any shape we want for our circuit. But the first step is to attach this interface to the circuit that we designed a few seconds ago. So from the options, select sub-circuit and part types. And from here, we create a sub-circuit symbol and select an open circuit attached to it. And if you click on this option, the circuit that we created now and the file that is open pops up. We select that and we press OK, and then we press done. Then you should be seeing all the ports of your circuit appearing as option to be selected for your symbol interface. Now, from the options, select auto create symbol. And from there, we are going to ask LogicWorks to automatically create a symbol with a default interface, default square interface for our circuit. Here you pick a name. This is the name that appears on top of the symbol whenever you drop it in another circuit. I'll call it full adder or FA. The text boxes you see around allow you to define where you want your ports. By default, we have the inputs on the left, outputs on the right. But if you want any of the signals anywhere else, select the name and move the name to the proper area. When it's ready, press the generate symbol. It will generate a default symbol interface for you. And if you notice on the left, none of the signals are red anymore. So that says everything your circuit has as the port, you have an interface port for it in your device symbol as well. So everything is attached. This is now ready. We can save this device symbol. Device symbols cannot be saved as single file. They go into the library. There will be a collection of symbols altogether. Example of other libraries that we have, if you look at the right palette, you see all the libraries that are loaded by default. They called .clf file, and they have a collection of different symbols. We are going to add another new library, which is our custom library for everything we are going to create. So let's save this device symbol. It will ask you what name you want to specify for your part and which library you want to save it in. It's best to not save into the default libraries. So let's create a new library. I press the new library button, and here I can select the path that I want my library to be saved. So I select the proper path. I'll name the library CPU project, and then we save. CPU project appears in the destination libraries. Select CPU project and select the name you want for your part. This name will be the name that you can filter your component and select it from the right palette at the end. So FA is the name I'm selecting, and I'll press save. Okay, FA appeared in the list of the components. And if you limit the selection of libraries to CPU project library, you will see that's the only component in the library. Right, that's the second step. The next step is to test that this symbol is working. Let's open a new circuit. In the new circuit, I'll select the symbol that I created just now and drag and drop it into the circuit. The way that I'm going to test this test bench is exactly the way that I tested the original circuit that we created a few minutes ago. Go back here, we'll attach a couple binary switches, and then we test a few different combinations of the truth table. So let's bring binary switches. We need 3 binary switches. Okay, binary switches attached. Simulation starts automatically as soon as you drop a binary switch. Let's stop, configure the simulation to show the values. So we see all the values of the wires. And then we can start the simulation by pressing the run simulation button. Let's test a few different combinations of the truth table again. First combination, all the inputs 0, outputs all 0. Second combination, all the inputs set to 1, the outputs both set to 1. And the last one, let's have 2 of the inputs set to 1 and 1 set to 0. So I set C in and B to 1 and set A to 0. And as we can see in this configuration, we produce the carryout correctly and sum is also 0. So that confirms our test bench is working as well, and our symbol is working as expected too. So we are all set and all done for this project. Let's stop the simulation and save this circuit with a new name. Let's call it 1-bit full adder 1-bit test bench. That's all for the project today.